You already know about 3i Atlas. You have been following this thing since it showed up on July 1st, 2025. You know it does not belong here. You know it came from somewhere else. You know scientists have been watching it with every major telescope on the planet, and a few off the planet too. But here's what most people are not talking about yet. The question is no longer just, what is it? The question is, what is it doing? Because right now in March 2026, 3i Atlas is sitting right at the edge of Jupiter's gravitational territory. And a small group of serious, credentialed scientists are looking at the data, the trajectory, the chemistry, the jets, the water, and they are arriving at a conclusion that mainstream astronomy is not ready to say out loud. This thing may not be passing through, it may be stopping. Subscribe to Space Aquarius and let's begin. Let's talk about Jupiter for a second because this is where the story gets real. Jupiter is not just a big planet. It is the gravitational king of our solar system. Every other planet combined does not match Jupiter's mass. Its zone of gravitational dominance, what scientists call the Hill radius, stretches out roughly 33 million miles from the planet's surface. That is the boundary where Jupiter's gravity starts to overpower the Sun's pull. And as of mid-March 2026, 3i Atlas is right at that line. Now here's what you need to understand about why that matters. When a natural comet drifts into Jupiter's gravitational zone, the math is straightforward. Orbital mechanics takes over. Scientists can calculate exactly how Jupiter's gravity will bend the object's path. It is predictable. It has been predictable for centuries. But 3i Atlas has not behaved like a natural comet from the beginning. Not even close. And if it does not behave like one now at Jupiter, then we are in genuinely uncharted territory. Think about the route this thing took to get here. Our solar system is laid out like a flat disk. The sun in the middle, all the planets orbiting in roughly the same plane, like coins spinning on a tabletop. If a random rock from deep space tumbles in from the galaxy, you would expect it to come in at a steep angle. Random objects from random directions do not naturally line up with someone else's solar system layout. 3i Atlas came in tilted just 5 degrees off that flat plane. 5 degrees. Nearly perfectly aligned with the orbital plane of every planet in our solar system. The odds of a random interstellar object arriving at that angle by pure chance? 0.2%. On its way through, 3i Atlas made close approaches to 3 major planets. It passed within about 29 million miles of Mars in early October 2025. It reached its closest point to the Sun on October 29th, 2025, and now it is at Jupiter. When you combine the probability of that precise alignment and those 3 planetary close approaches happening by random chance, Loeb's team put the number at roughly 0.005%, 1 in 20,000. And there's one more detail that does not get talked about enough. When 3i Atlas reached perihelion, its closest and most critical point to the Sun, the moment when the most important activity would be happening, Earth was on the exact opposite side of the Sun. We could not observe it at all. If you were designing a spacecraft to carry out operations without being watched from Earth, you could not have engineered that timing any better. Now let's get into the water, because this is where the colonization theory starts to take real shape. After perihelion, a spacecraft called the Solar and Heliospheric Observatory, SOHO, detected a massive cloud of hydrogen surrounding 3i Atlas. Scientists calculated that in just 1 month of observation, this object released approximately 13.5 million metric tons of water. That is not a typo. 13.5 million metric tons in 30 days. Now, water in a comet is not unusual by itself, but the scale here is extraordinary. And more importantly, water is not just water when you are talking about space travel. Run an electrical current through water, and you split it into hydrogen and oxygen. That process is called electrolysis. Hydrogen and oxygen are 2 of the most powerful rocket propellants ever used. Every major space program on Earth has used them. The space shuttle's main engines ran on liquid hydrogen and liquid oxygen. So what you have here is an interstellar object carrying a massive, self-replenishing fuel supply. The exact ingredient a propulsion system would need to slow down, maneuver, and establish position inside a new solar system. Loeb published a paper in January 2026 laying this out directly. He called it interstellar hitchhiking. The concept is straightforward. For any civilization living on a planet with gravity, like Earth, Launching a spacecraft fast enough to cross the distances between stars requires an almost unimaginable amount of energy. The fuel costs alone would be staggering. But what if you did not build the rocket? What if you just caught a ride? Interstellar objects like 3I Atlas travel between star systems naturally. They get ejected from their home solar systems, drift through the galaxy for billions of years, and occasionally pass through other systems. They are free transportation. Loeb's proposal: an advanced civilization could attach a small technological payload to one of these objects. The object carries it across the galaxy. When it enters a new solar system, the payload uses the object's own water, split through electrolysis, to maneuver, adjust course, and explore. And then he pointed to the jets. The Hubble Space Telescope captured detailed images of 3I Atlas showing 3 distinct jets shooting out from its nucleus. Those 3 jets are spaced almost exactly 120 degrees apart from each other. Equal spacing, like 3 points on a perfect triangle. Natural comets do not do this. Natural comets vent gas and dust randomly, wherever the ice happens to be, wherever sunlight hits the surface. The result is always uneven and unpredictable. Equal 120-degree spacing suggests design. Loeb published a paper specifically addressing this geometry. He noted that a system of thrusters arranged in this configuration would be exactly what you would engineer for stable, controlled navigation of an interstellar vehicle. 3 equally spaced thrusters provide balanced thrust in any direction. It is the same logic engineers use when designing spacecraft attitude control systems right here on Earth. And the jets are not static. Hubble observations from November 30th, 2025 showed the entire jet system wobbling periodically, rotating around the object's axis with a period of 7.2 hours. That kind of regular periodic motion is consistent with a controlled rotation, a spin-stabilized vehicle. On top of all that, the chemistry of 3I Atlas does not match anything in our solar system. New research published in March 2026, using data from the James Webb Space Telescope, found that the water inside this object contains deuterium, a heavier form of hydrogen, at levels more than 10 times higher than any comet ever studied. Its carbon isotope ratios fall outside the range of anything found in our solar system, in nearby interstellar clouds, or in protoplanetary disks. The researchers concluded that 3I Atlas likely formed somewhere between 10 and 12 billion years ago, more than twice the age of our solar system, in a region of the early galaxy with very different chemistry than anything near us. This object is ancient, it is foreign, and its fingerprints do not belong here. So, back to Jupiter. Here's what Loeb and others have pointed out about why Jupiter specifically matters in this scenario. Jupiter is not just a gravitational obstacle, it is a resource. Its moons, particularly Europa, Ganymede, and Callisto, are believed to contain vast oceans of liquid water beneath their icy surfaces. Europa alone may hold twice as much liquid water as all of Earth's oceans combined. If 3I Atlas is carrying a technological payload that runs on water-derived propellant, Jupiter's moon system is essentially a refueling depot on a galactic scale. And Jupiter's gravitational field, rather than being a threat to an incoming object, could actually be used as a braking mechanism, a way to slow down and establish a stable orbit without burning through your own fuel supply. Space agencies do this all the time. It is called a gravity assist. You use a planet's gravity to change your speed and direction for free. The difference is that when NASA does it, we call it clever engineering. When a 12-mile wide interstellar object does it on a trajectory that had a 1 in 20,000 probability of occurring naturally, people start asking harder questions. ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently on its way to Jupiter and arriving in 2031, already photographed 3I Atlas on November 6, 2025, from a distance of about 41 million miles. The images showed a bright coma surrounded by long filaments of gas and dust. Scientists on the JUICE mission are currently analyzing spectral data collected during that observation window, with first findings expected in late March 2026. We are about to get a much clearer picture. Here is where things stand right now. 13.5 million metric tons of water released in 1 month. 3 jets spaced exactly 120 degrees apart. A trajectory with a 1 in 20,000 probability of occurring by chance. A chemical composition that matches nothing in our solar system. an object that is 10 to 12 billion years old, and a perihelion passage that was perfectly hidden from every telescope on Earth. Every single one of those facts is documented, published, peer-reviewed. What nobody can tell you yet is why. Maybe this is the most extraordinary natural comet the universe has ever produced. Maybe the galaxy just got strange for a moment and we happened to be watching. Or maybe something built this, something sent it, and it has been traveling for 10 billion years with a destination in mind. And that destination has 4 moons with liquid water oceans and the most powerful gravitational field in our solar system. After Jupiter, the current trajectory carries 3I Atlas toward the Gemini constellation, out of our solar system and back into the deep galaxy. But Loeb wrote something in his January 2026 paper that has stayed with me. He said that if interstellar hitchhiking turns out to be a common practice among advanced civilizations across the Milky Way, we might one day land our own equipment on a passing interstellar object and find that it already has equipment on it. We might not be the first ones to think of this. We might be reading someone else's travel journal. The James Webb Space Telescope is still watching, JUICE is still collecting data, and the trajectory data from the Jupiter encounter is still coming in. We are living through something that has never happened in recorded human history. If this video made you think, subscribe to Space Aquarius so you do not miss what comes next. Drop a comment below and tell me what you think. Natural comet or something far more extraordinary? And if this one got under your skin, share it with someone who needs to hear it. They will thank you later.